Since we have learned the theoretical part of shear modulus, it's time now to go for some problems based on what we have learned here. So here is the first problem coming for us, and it says that an aluminium tube of length 2 meters has inner and outer diameters of 3.0 centimeters and 4.6 centimeters respectively. Calculate in part A the torsional rigidity of the tube, and in part B the torque required to twist the tube to 1.8 degree about its axis. So we have learned the relevant formulas for this, and I'm sure the figure is fresh in your memory, so you can go straight for it. As they have said, let us write down the data given. The length of the tube, which we'll be assuming to be a cylindrical body, length is 2.0 meters. The inner radius will be requiring R1 is equal to the inner diameter d1 by 2. d1 is given to be 3.0 centimeter divided by 2. This is coming out to be 0.015 meter in two significant figures in SI unit. And similarly, the outer radius of this hollow cylindrical tube is given by d2 by 2. Outer diameter was given to be 4.6 centimeters divided by 2. This is coming out to be 0.023 meter in SI unit once again. We have been further given that the angle of twist of this tube is phi, that is 1.8 degree. I am listing the data for future use. Now, we require in the first part to calculate the torsional rigidity of the tube, and you have the formula for that. Torsional rigidity, capital C, is given by the formula pi into capital G into R2 to the power 4 minus R1 to the power 4 divided by 2L. We have learned this formula earlier. Here for a hollow tube, G is the shear modulus of the material aluminium of which the tube is made. R1, R2 are the inner and outer radii already listed. L is the length of the tube already known. So you can just put the values. Before that, I need the value of G for aluminium. I said some time back, as well as you can refer to any standard table and can find out the value of shear modulus for aluminium is 2.5 into 10 to the power 10 Newton per meter square in two significant figures. So we have got all the data here in two significant figures, and while reporting the answer, we shall remember that. So putting the value straight away, you can write down torsional rigidity C is coming out to be pi. The value of G is 2.5 into 10 to the power 10 Newton per meter square. Inside the bracket, outer radius R2 was 0.023 meter. This is whole to the power 4 minus R1 to the power 4. That is 0.015 meter. Again whole to the power 4. This is numerator divided by twice L. L has been given to be 2.0 meter. Complete the calculation and show that the value of C is coming out to be 4.5 into 10 to the power 3 Newton meter. You can go for a dimensional check here. As you can see, I'm showing it somewhere here, Newton per meter square, the unit of G. Then you have got here inside the bracket, unit is coming out to be m to the power 4, and then in denominator once again meter is coming. So you can see here indeed the unit is coming out to be Newton meter. Therefore, we corroborate this dimensionally, and our answer for the first part of the question is the torsional rigidity of the tube in question is 4.5 into 10 to the power 3 Newton meter. Moving on to the part B of the question, they want us to find out the torque required to twist the tube to 1.8 degree about its axis. And here I've got a formula for that again. We have learned some time back. The torque required is given by torsional rigidity C of the tube multiplied by the angle of twist expressed in radians. This part you mustn't forget. So I have been given data on the phi in degrees, and while putting the values, I must be mindful. The value of C was found in part A to be 4.5 into 10 to the power 3 Newton meter, and the value of phi was 1.8 degree, converting into radian 1.8 into pi upon 180 radian, is not it? The conversion factor 1 degree is equal to pi upon 180 radian, pi being 3.14. So just make the calculation and show that the value of tau, we are getting it to be, well, 141.37. This much I got, Newton meter. But here is the catch. You should report the answer in 2 significant figures as consistent with the data of the problem. So I should say this is, I must round up 2 significant figures and report it to be 140 Newton meter. That is my answer. If you give it to be 141 Newton meter, I have no objection, but I shall myself say that the torque required is 140 Newton meter. This is the answer of the part B of this question.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.